We know that life is dependent upon the flow of energy and a cycling of matter. When you're going from molecule A to molecule E in a metabolic system, you have lots of small controlled steps. We're dealing with a coupling of exergonic and endergonic reactions, which means we're dealing with a whole lot of energy. So by having all of these small, tiny steps, we don't release too much energy at once. We have a great deal of efficiency and a great deal of control. Plus, say for example, I need an intermediate compound. Say I need a compound C for a particular reaction. Well, I just don't apply enzyme 3 and compound C is created. So it's a very efficient process. You may remember from 7th grade consumers and producers. Now we're going to go a little bit beyond that, and we have autotrophs, which are organisms that make their own food, and heterotrophs, organisms that have to eat other organisms. Now we need the flow of energy to maintain life. Now, what is the main source of energy for life on the planet? The sun. The sun gives energy that the plants use, the autotrophs use, the producers use, and that energy is then consumed by an herbivore or a primary consumer, which is a heterotroph. Now that organism and the plant itself is going to be using the energy to create ATP for biosynthesis, reproduction, and so on. But it is also going to need raw materials, carbon sources. Now animals produce CO2, which plants use as their carbon source, which is this whole cycle. Now we also need essential nutrients, which is the materials that we can't make ourselves. Oxygen, nitrogen, phosphorus. Now, this process doesn't stop, of course, with the primary consumer. You go until you reach at least a secondary consumer or beyond, and that was another layer of heterotrophs feeding on an already heterotrophic organism. But once you have that food, the way you use the food is determined by your energy budget. Now, the energy budget is going to be different from organism to organism and from location to location, but the general energy budget is going to have a 3-tiered system. The first use of energy will be for ATP, maintaining that resting metabolism, maintaining the temperature, doing the activities that your body requires. Once you have done that, you'll go through biosynthesis, which will repair, grow, and reproduce anything that makes new molecules, and then whatever is left over goes into storage. And in animals, we store it as either glycogen, which is a sugar, or fat. Living systems move electrons as part of a hydrogen atom. They can't just transfer electrons around. That's a problem. So we use electron carriers as an intermediate. Now, electron carriers, they use a process called redox, or reduction and oxidation. The hydrogens are transferred from the oxidized to the reduced. That means that it's going to be able to carry a little bit of extra energy. The two most important electron carriers in cellular respiration are NAD+ and FAD+2, arguably two of the most important coenzymes in the cell. Now, NAD+, which we know as niacin or vitamin B3, is more preferred because it releases more energy. FAD+2 or riboflavin or vitamin B2, not as useful, not as much energy, but still essential to the process of cellular respiration. So energy is transferred from one molecule to another via redox reactions. So looking at the example below, I have C6H12O6 or glucose turning into CO2. So I go from a 1-to-1 carbon to oxygen ratio to a 1-to-2. So in the oxidation step, I added oxygen and I removed hydrogen. Therefore, I released energy. Now, on the other side, my reduction step, I added hydrogen. So oxygen becomes water. That is going to store energy and be an endergonic process. When you take in food or high energy molecules, you must break down that food. It's the whole point of metabolism. Now, there's two major ways you can do that. The first way is combustion. You make heat energy by burning fuel in one big step. So burning of a log to make a fire is combustion, lots of energy. But let's look at an example of this. So as you just saw, the combustion reaction is extremely violent. Now imagine if that happened every time you ate something. Okay, that's not going to be good for you. You need to release energy in many small controlled steps, and that process is what's known as respiration. So when you see the formula for cell respiration, what's really happening is a bunch of small steps, which we're going to look at later, but it's a controlled release of energy and heat so that you don't, well, explode. Now, as we begin to learn about cell respiration, we are only going to be learning about a very narrow type of cell respiration, which is using glucose to get energy. So it's only one type, only one source. There are many other sources, as you can see here, but don't worry, we're only going to learn the one. I just want you to be aware that though you learn cell respiration formula with glucose, that is not the only form of metabolism in the body.